We are going to see numericals for all the chapters for 12th physics. So first chapter we have is rotational dynamics, and let us start with numericals for first chapter. So it is given to us that in the first question, question number 12 on page number 24 of our textbook, somehow an ant is stuck to the rim of a bicycle of diameter 1 meter. This is given to us in the question. The diameter of the bicycle which is given to us is 1 meter. So let us note the given data that diameter is 1 meter. So always I have told you, whenever we have been given diameter, first find the radius. So radius will be 0.5 meter. Diameter 1 meter, radius will be 0.5 meter. While the bicycle is on a central stand, the wheel is set into rotation and it attains a frequency of 2 revolution per second in 10 seconds. So this is given to us ki the wheel is on central stand. The wheel is on central stand means it is not moving. The bicycle is on central stand means bicycle is not moving. It is on central stand means it is at rest. The bicycle is at rest, and when it is on its stand, you are just moving the wheel of the bicycle. So it attains a frequency of 2 revolution per second. So initially it was at rest because the bicycle is on the central stand, means bicycle is at rest. It is at rest. So since the bicycle is at rest, I can say the initial frequency is 0 rps. Rps means revolution per second. So initially, since it was at rest, the frequency will be 0, n1 will be equal to 0 rps. Rps means revolution per second. And after you set it into rotation, it is said that the frequency is 2 revolution per second. So second frequency is given to you, that is 2 rps. So I can say n2 is 2 rps in time 10 seconds. So they have given time 10 seconds is also given to us. With uniform acceleration, there will be some uniform acceleration. Let us see that. Number one, the first thing is to calculate the number of revolutions completed by the ant in these 10 seconds. So the first thing that you are supposed to find is the number of revolutions. Remember that number of revolutions has a formula. Number of revolutions denoted by capital N is angular displacement upon 2 pi, that is theta upon 2 pi. This is the formula to calculate the number of revolutions. Number of revolutions, capital N, is equal to theta divided by 2 pi. Theta is the angular displacement divided by 2 pi. So that means to find N, I will have to first find theta. So using kinematical equations which are given in rotational dynamics, theta is equal to omega naught t plus half alpha t square. These equations are kinematical equations which are similar to linear motion. We have discussed in class also, and this is given in our textbook also. These are the kinematical equations, like the equations which we have: v square equal to u square plus 2as, s equal to ut plus half at square. So this is a kind of that equation. This is similar to s equal to ut plus half at square. S is the displacement, here theta is the displacement, angular displacement. U is initial velocity, here omega naught is the initial angular velocity. A is the acceleration, here alpha is the angular acceleration. So when you compare this, you can compare this with s equal to ut plus half at square. Ut plus half, this equation was in linear motion when we have discussed linear motion in lower classes, and this is in case of a rotational motion. So students should remember all the kinematical equation, whether it is linear motion or rotational motion. Both kinematical equations are necessary to be known. So similarly, we have other equations also, like we have s equal to ut plus half at square. We have v square equal to u square plus 2as. We have v equal to u plus at, and other same equations in rotational also. So anyway, now we only require this equation: theta equal to omega naught t plus half alpha t square. So omega naught is the initial angular velocity. So I can say omega naught will be equal to 0. Why? Because n1 is 0. Okay, before writing this omega naught is 0, I will let you know that omega naught, the value, the formula for omega in terms of frequency is 2 pi n. So I can write 2 pi n1, and since n1 is 0, I can say omega naught is 0 radian per second, because n1 the first frequency is given as 0, so omega naught will be 0. तो ओमेगा, फाइनल ओमेगा जो है वो कैसे मिलेगा? ओमेगा विल बी इक्वल टू 2 पाई n2, and that will be equal to 2 pi into 2. n2 का value is given to you as 2 rps, so 2 pi into 2, that will be 4 pi radian per second. So the second frequency that is given to you is 4 pi radian per second. So omega naught, we have obtained omega naught is 0. And now I have taken omega because we know that alpha is change in omega per unit time. alpha. The formula for alpha is change in angular velocity per unit time. So change in angular velocity matlab omega minus omega naught upon t, right? Change in angular velocity matlab final angular velocity minus initial angular velocity. So final angular velocity is 4 pi, initial angular velocity is 0. So alpha will be equal to 4 pi minus 0 upon t is given as 10. So 4 pi by 10. You can keep it as 4 pi by 10 radian per second square. The unit for alpha is radian per second square. So I have found out omega naught, that is 0. I have found out alpha. Now I can find out theta. So therefore theta will be equal to 0 into t plus half into the value for alpha is 4 pi by 10 multiplied by time square, that is 10 square. So again here theta will be equal to 0 plus, when you solve this equation you will get half into 4 pi by 10 into 10 square, you will get the equation as 20 pi. When you solve this you get it as 20 pi. So theta equal to 20 pi radian. The value for theta which you will get is 20 pi radian. So theta हमें मिल गया है 20 pi radian, but we are not interested in theta. We need the value of number of revolutions, that is n. So as I told you, n equal to theta by 2 pi. So theta by 2 pi means is 20 pi by 2 pi. So that will be 10 revolutions. So the answer is 10 revolutions. So the answer for first case is n is given as 10 revolutions. Second thing is asked is time is taken by it for first complete revolution and last complete revolution. Two things we are supposed to find, two time we are supposed to find. One is for first revolution, other one is for the last revolution. Now see, we have already noted that there are 10 number of revolutions. So 10 number of revolutions, my first revolution will be 1. Obviously first revolution will be 1. The last revolution will be the 10th revolution, right? So the second case, again we will use the same formula, theta equal to omega naught t plus half alpha t square. We will take out with the same formula. Now in case of first revolution, for first revolution, I can say my theta will be equal to 2 pi. One circle, one angular displacement is of 2 pi. Two angular displacement will be 2 into 2 pi, that is 4 pi. Three angular displacement will be 3 into 2 pi, that is 6 pi. We all know this, that the one revolution in radians is 2 pi. So I can write theta is 2 pi, right? Using this I can find the time. So 2 pi will be equal to omega naught is 0, 0 plus half alpha value which I have got 4 pi by 10 into t. So t square I need to find out in this case. Okay. So I will write it as t1 because time required for first and last. Na? So I will write it as t1 and t last. Okay. So I need to find your t1 value. So when you solve this equation, so what do you get over here? You get t1 square equal to 10 seconds. You get t1 square equal to 10 second, or I can say t1 equal to root 10 second. So you have got the value for t1, that is root 10 seconds. This is the first revolution के लिए time लगेगा. The time taken for the first revolution will be given by this. You solve this equation, 2 pi equal to half into 4 pi by 10 to t1 square. I hope students will be able to do normal basic calculation. I'm not going to deal with that. I'll be just explaining and writing the answer. So t1 will be equal to root 10. So this was for the first revolution. Now we need to find the last revolution also. Okay. So there are two things which is asked in the same question: time taken by to complete the complete revolution, first complete revolution, and last complete revolution. See, these are two different things. Time is taken by it for first complete revolution. First पूरा circle होने के लिए कितना time लगेगा, and last full circle complete होने के लिए कितना time लगेगा. So time taken for last, that is the 10th revolution. There is a shortcut formula which I can use directly over here. So the time taken for 10th revolution will be given by 10 minus time taken for 9th revolution. This is the formula which we can use. I know this is not there in the textbook also. This type of sums are directly given in the exercise. So, but anyhow, let us deal with some problems. The time taken for 10th revolution is equal to 10 minus time taken for 9th revolution. I want students to please remember this formula for at least for this case. The time taken for the last revolution will be equal to, in general, if I tell you, the time taken for last revolution will be equal to total number of revolutions minus time taken for n minus 1 revolution. Suppose if I take one example, if there are 100 oscillation के लिए पूछा गया, now here we got 10 revolution as our answer, that's why I'm taking over here 10, right? In case अगर ये 100 आता, तो what will our formula will be? The time taken for 100th revolution will be equal to 100 minus time taken for 99th revolution. I hope you all are understanding. ठीक है, जो number of revolutions में से लास्ट वाले का टाइम माइनस करना है, ठीक है, so that way you can get the last revolution के लिए टाइम. Now, so here our task again is to find the time taken for ninth revolution. So time taken for ninth revolution will be similarly as you have found out for first. Okay, similarly as you have found out for first. So time taken for ninth revolution will be again theta will be equal to omega naught t plus half alpha. I will write here t9 square. T9 for ninth revolution. Now first revolution के लिए it was 2 pi. So ninth revolution के लिए 9 into 2 pi, that will be 18 pi. So angle theta will be 18 pi. Omega naught is 0. So 0 plus half 4 pi by 10 into t9 square. So when you solve this, you get the value for t9 as 9.48. You get the value for t9 as 9.48 second, or you can say t9 square is equal to 90. T9 square you will get 90. Okay, I'm letting you know. You can just check it by doing the calculation. When you solve ना, you will get t9 square as 90. तो t9 निकालने के लिए root 90 निकालेंगे, right? t9 square is equal to 90. So when you take square root of 90, you get 9.48. Okay, so the time taken for ninth one is 9.48. Therefore, the time taken for last revolution, time taken for 10th revolution will be 10 minus 9.48, and when you solve this, you get the answer as 0.52 second. Okay, it will be 0.52 second. I know it is a lengthy question, but anyhow, we will have to deal with such questions also. Always we will not get easy questions. So please remember. So I'll just quickly revise you once again. We have been given the diameter as 1 meter, radius as 0.5, time as 10 seconds. The first frequency will be 0 because the bicycle is on rest. Second frequency they have given 2 RPS. We need to find first case number of revolution. Number of revolutions, the formula is theta upon 2 pi. We will find theta using omega naught t plus half alpha t square, this formula, kinematical equation. Initial angular velocity will be 0 because first frequency is 0. The final angular velocity will be equal to 2 pi into n2, that is equal to 2 pi into 2, that is 4 pi radian per second. And we know that from here, we know that alpha is d change in omega upon change in time, change in angular velocity upon time, d omega by dt. So change in omega will be omega minus omega naught upon t, that is 4 pi minus 0 by 10, that is 4 pi by 10. You can solve this 4 pi by 10 also, but I suppose if you don't solve, that will be better, because if you see here na 10 10 यहाँ से cut हो जाएगा. So that will be better if you don't solve, because that will make you easier for calculation. So now when you substitute the value, you get theta is 20 pi, and number of revolutions will be equal to 20 pi upon 2 pi, that is 10 number of revolutions. That is our first case. For second case, we need to find time taken for the first complete revolution, time taken for the last complete revolution. So since we have got the number of revolution as 10, the last revolution will be the 10th revolution, and the equation will be the same, theta equal to omega naught t plus half alpha t square. For first revolution, I will write it as t1. For last revolution, you will use the formula time taken for 10th revolution will be 10 minus time taken for 9th revolution. That is the formula. And lastly, you will solve for 9th revolution similarly, and you will subtract. That will be your answer. Next question. The coefficient of static friction between a coin and a gramophone is given as 0.5. We have been given with the coefficient of static friction, coefficient of friction between the two things is given to us, that is 0.5. So let us write mu, coefficient of static friction is mu, that is 0.5. The radius of the disc is 8 centimeter. It is being given to us, the radius of the disc is 8 centimeter initially. So let us write radius, say r. Radius r is given to us, or let us take capital R. Capital R. I'll take capital R as the radius. Let us assume capital R is given to us as 8 centimeter. Converted to meter, 8 into 10 raised to minus 2 meter. It is always necessary you convert it to SI unit. Please remember. Okay. So radius is given as 8 centimeter. Initially, the center of the coin is 2 centimeter away from the center. Let us take one diagram to explain you. Suppose this is a disc. This is the axis through which the gramophone is being placed, and there is a coin which is placed on this particular gramophone. There is a coin which is placed. Now initially they have told that the coin is placed 2 centimeter away from the disc. They have told the coin is placed 2 centimeter away from the center. So if this is the center, इससे 2 centimeter assume इधर होगा, इधर coin रखा हुआ है. Suppose here is the coin which is placed. ठीक है, assume ये total जो radius है, this is given to us as 8 centimeter. The radius of the disc is given to us as 8 centimeter, and ये जो नीचे वाला distance है, that is given to us as a 2 centimeter. From the center it is 2 centimeter away. The question is asking at what minimum frequency will it start slipping. Frequency पता करना है. Suppose n is the frequency that we are supposed to find. At what minimum frequency will it start slipping from there? By what factor will the answer change if the coin is almost at the rim? Okay, so there are two cases given. So in case of case 1, this is told you कि coin is at a distance of 2 centimeter from the center and the radius is 8 centimeter. In second case, they have told, let me draw for second also. So this is the gramophone, this is the center, this is the radius, this is the axis of rotation. Okay. So in second case, case 2, you don't need to draw the diagram. I'm just explaining that for your convenience. Okay. Exam में diagram draw नहीं करना है. It is just for your understanding. So in the case of second case, they have been told that radius to same hai, but the by what factor will the answer change? Means again you are supposed to find the frequency only. So let us give this as n1, this as n2. By what factor will the answer change if the coin is almost at the rim? Almost at the rim मतलब एकदम end पे, यहाँ पे coin आ गया. Now if you see, radius भी 8 centimeter होगा and coin and this coin and center के बीच में भी distance 8 centimeter होगा, right? So I'll write this as distances r1 and r2 is given to us. Let us assume the distances which are given to us is r1 and r2. So in first case, r1 is given as 2 centimeter. In the second case, r2 is given as 8 centimeter. r1 and r2 are the distance of the coin. फ्रॉम वेयर, फ्रॉम द सेंटर. सेंटर से कॉइन कितना दूर है? फर्स्ट केस में सेंटर से कॉइन कितना दूर है? 2 सेंटीमीटर. इन सेकंड केस दे हैव टोल्ड इट इज ऑलमोस्ट एट द रिम, मींस एकदम एंड पे आ जाएगा, तो जितना रेडियस होगा उतना ही डिस्टेंस होगा. सेम, इट विल बी सिमिलर. सो r2 विल बी 8 सेंटीमीटर. नाउ सिंस इफ यू सी वेरी केयरफुली, द कॉइन इज स्लिपिंग ना, पहले 2 सेंटीमीटर के डिस्टेंस पे था, अभी 8 सेंटीमीटर के डिस्टेंस पे आ रहा है, मींस इट इज स्लिपिंग फ्रॉम द सेंटर, इट इज गोइंग अवे फ्रॉम द सेंटर. The force which is acted, which is going away from the center, is called a centrifugal force. So centrifugal force will be taken place over here. Centrifugal force should be equal to the force of friction. Centrifugal force should be balanced by the force of friction. Why centrifugal force? I repeat once again, if you read the question very carefully, you will find that the coin is going away from the disc. So जो force away जाता है उसको बोलते हैं centrifugal force. So in case of centrifugal force, we have the formula mr omega square. Mr omega square will be equal to force of friction is given by mu mg. Force of friction is given by mu mg. This is the 11th standard formula. Force of friction is mu mg. mm cancel. r into omega. Omega, अच्छा हमें n1 पता करना है. अभी पिछले क्वेश्चन में I have told you omega can be written as 2 pi n, right? So I will write it as 2 pi n into mu g. ठीक है? So I will get it as, I will rewrite as r1 into 2 pi n1 equal to mu into g, right? If you see here very carefully, they have given to you g is equal to pi square, and I want you to please remember this value. You have to remember this value. ये बहुत helpful value है. Value of g is always equal to pi square. This is very useful in calculations. ठीक है? Actually, the value of g is 9.8 and pi square का value भी 9.8 आता है. When you solve pi square basically it will give you 2-3 digit का figure है, but initial 2 digit is 9.8. So g is equal to pi square. Sometimes you can take 10 also. It is okay. So r1 into 2 pi n1 equal to mu g, right? So what can I do? I need to find r1. अच्छा, ये square आएगा इसका, because omega square है ना, so bracket का square. So I need to find here n1. So what I can do, r1 into 4 pi square n1 square equal to mu into g के जगह पे pi square. फिर ब्रैकेट ओपन कर दिया, वो ओपन द ब्रैकेट्स. 2 pi n1 स्क्वायर है ना, उसका ब्रैकेट ओपन कर देंगे, स्क्वायर कर देंगे, तो 4 pi square n1 square equal to mu pi square. Now see, this will be very helpful. The value of g which is given to you, this is very helpful because pi square cut हो जाता है. So what you are left out with? You are left out with n1 square equal to only mu upon r1. That's it. Only this much. n1 square equal to mu upon r1. And mu भी दिया हुआ है क्वेश्चन में, r1 भी दिया हुआ है. So mu is 0.5. r1 is 2 centimeter. You have to convert 2 into 10 raised to minus 2. r2 will be equal to 8 into 10 raised to minus 2 meter. Okay. So when you convert this 2 into 10 raised to minus 2, and so you will get this as n1 square. So when you solve this, you get this n1 square value. n1 square will be equal to 0.5 upon 2 into 10 raised to minus 2. So when you solve this, you get n1 value as, okay. So when you solve this, you get n1 equal to 2.5 rps. This is the value for n1. On solving this, you get the value of n1, that is 2.5 rps. Same way I need to solve it for second case also. Same way I will have to solve it for second case also. So I'll just erase the given data over here. Okay, so we have the second case that we are supposed to find similarly. I'll just write it here only. Second case also similarly you will have to do. ये पूरा नहीं solve करना है, directly you can write. Similarly ये पूरा same method रहेगा, पूरा ये सब calculation same रहेगा. Similarly I can write n2 square equal to mu upon r2. Simple, that's it. ठीक है, हमने एक के लिए डिटेल में सॉल्व कर दिया ना, सेकंड के लिए सॉल्व करने का जरूरत नहीं है. यू कैन राइट सिमिलरली एंड राइट n2 स्क्वायर विल बी म्यू अपॉन r2. जैसे n1 स्क्वायर म्यू अपॉन r1 मिला, सेम कैलकुलेशन करके n2 के लिए भी मिल जाएगा. n2 स्क्वायर विल बी म्यू बाय r2. म्यू इज 0.5, r2 is 8 into 10 raised to minus 2. That is given to you. So when you solve this, you get n2 square value. Okay, you will get n2 square as, or directly I can say n2 square as 1.5625, or I can say n2 is root of this value. Root of this value will be 1.25 rps. Root of 1.5625 will be 1.25. You can take the square root and check that. Second thing which they have asked is by what factor will the answer change. By what factor will the answer change means you have to divide n1 and n2. तो फैक्टर मिल जाएगा. कभी भी फैक्टर पूछा है ना, यू हैव टू डिवाइड द टू वैल्यू. सो n1 कितना मिला 2.5, n2 कितना मिला 1.25. सो 1.25 into 2 करेंगे तो 2.5 होता है ना. 1.25 into 2 is 2.5, तो 2 is the factor. So therefore n1 upon n2 कितना मिलेगा 2. That is your final answer. It is the two factor से चेंज होगा. Next. A part of a racing track is to be designed for a curvature of 72 meter. You have been given radius of curvature 72 meter is given to you. We are not recommending the vehicles to drive faster than 216 kilometer per hour. kmph मतलब kilometer per hour. We are not recommending. We are not recommending means this is the most safe speed given to you. Most safe speed. Most safe speed. It is not the maximum speed, it is the most safe speed given to you, because they are just recommending. It is not a compulsion. You have to follow that. It is not a compulsion, it is just a recommendation that if you drive within this speed you will be safe, right? So it is just a recommendation. So that is the most safe speed denoted by vo. Optimum speed, we call it as optimum speed also, or a most safe speed. So that is given by 216 kilometer per hour. To convert kilometer per hour to meter per second, to convert this you multiply by 5 by 18. Please remember 1 kilometer per hour is 5 by 18 meter per second. Many students fail to understand this, but please remember this. 1 kilometer per hour value, 1 kilometer per hour को meter per second में always will have to convert. That is equal to 5 by 18. So when you convert this, you get 60. Answer as 60 meter per second. You get the answer as 60 meter per. This is velocity. Chalo, next, with what angle should the road be tilted? Angle of banking is asked. Angle of banking is asked in the question. What will be the angle of banking? Theta value you are supposed to find. By what height will its outer edge be with respect to the inner edge if the width is given? Width of the track is given as 10 meters. So height pata karo. So the first case that you will use is angle of banking. Angle of banking ka formula theta equal to tan inverse V naught square upon Rg. Or I can say capital R या small r whatever. चलेगा. So theta will be equal to tan inverse V naught square is 60 का square, 60 by 60 into 72 into 10. G का value approximately take it as 10. No problem, चलेगा. So theta will be equal to tan inverse of some number. So here when you solve, you get this number as 5. When you solve 60 by 60 into 72, 60 by 60 divided by 72 into 10, you get the answer as 5. Theta equal to tan inverse 5. Tan inverse 5 is 78 degree 68 minutes. 78 degree 68 minutes. Please refer my logarithm playlist videos. You will find there how to find the value of this tan. How did I calculate this tan inverse 5? I've explained in that logarithm का एक playlist है, उसमें मिल जाएगा value. How to find natural sine, natural cos, natural tangent का ये values कैसे पता करना है. There is separate video, so you can please go and refer that if you don't know how to solve. If you know, the very good. Chalo. So theta is given to you 78 degree 68 minutes. This is your first answer. Second case, they have been told you have to find the height with what the uh, okay. So in angle of banking, this is the horizontal road. This is the angle with which it has been banked. ये height हमें पता करना है. And this width is been given to you. This width is given to you, that is 10 meter. The height, the vertical height you are supposed to find. जो base है ना, ये road है, ठीक है. ये width है, इतने angle पे ये banking किया हुआ है road का. So which angle, if you see opposite upon hypotenuse, opposite is height upon hypotenuse is width. तो ये opposite upon hypotenuse क्या होता है, sin theta. तो यूज sin theta. So h कितना हो जाएगा, width into sin theta. थीटा क्या लेंगे, जो फर्स्ट केस में मिला 78 डिग्री 68 मिनट्स. तो h will be equal to 10 into sin 78 degree 68 minutes. Again you can refer sin का वैल्यू कैसे निकालना है. तो when you see, you get the value as 10 into the value is something 0.982. 0.982. So h will be equal to 9.82 meter. That is your height. H will be equal to 9.82 meter. That is the height. Next, the road in the question 14. That means data from question 14 you will have to take. Okay, all the given data you will have to take from question 14 itself. ठीक है, पिछले वाले क्वेश्चन में जो भी ये वैल्यू आर का वैल्यू, स्पीड का वैल्यू जो भी लगेगा, we will use this values. Above is constructed as per the requirement. The coefficient of static friction, this is given to you. Coefficient of static friction is given to you 0.8. Will there be any lower speed limit? You have been asked to find will there be any lower speed limit. Please remember students, lower speed limit मतलब minimum velocity कुछ पता करना है. अच्छा कितना होगा, by how much can the upper speed limit exceed in this case? So first find the minimum velocity. V minimum का value, that is root rg tan theta minus mu upon 1 plus mu tan theta. This is our formula to find the minimum velocity. So everything is given to you. रूट आर का वैल्यू पिछले सम से लेना है 72 इंटू 10 इंटू tan theta. Tan theta का वैल्यू tan of the angle which is given to you. Tan of the angle is 78 degree 68 minutes. ठीक है, tan of 78 degree 68 minutes. tan 78 degree 68 minutes. उसका आंसर 5 आता है. देखो tan इनवर्स 5 इज दिस वैल्यू ना, तो इसका रिवर्स करना है हमें. tan ऑफ 78 डिग्री 68 मिनट्स क्या हो जाएगा, 5 हो जाएगा, राइट. इसका रिवर्स करना है, तो आंसर विल बी 5. बट एनी हाउ वी विल हैव टू राइट माइनस 0.8 डिवाइडेड बाय 1 प्लस tan 78 डिग्री 68 मिनट्स. ठीक है, so when you solve this you get this is root 720 into this is as I told 5 minus 0.8 divided by 1 plus 5, right. So when you solve this you get the answer as the answer will be nearly 24.59 meter per second. The answer is 24.59 meter per second. Textbook में they have given the answer in kilometer per hour. We need to keep it in SI unit only. तो मीटर पर सेकेंड में ही रखो, ठीक है. कीप इट दिस आंसर ओनली. टेक्स्ट बुक में दे हैव कन्वर्टेड मीटर पर सेकेंड टू किलोमीटर पर आवर. जैसे यहाँ पे हमने किलोमीटर पर आवर को मीटर पर सेकेंड में किया था, तो मीटर पर सेकेंड को किलोमीटर पर आवर में कन्वर्ट करने के लिए क्या करेंगे, यू मल्टीप्लाई बाय 18/5. इसका उल्टा से मल्टीप्लाई करना, ठीक है. 18/5 से इस नंबर को 18/5 से मल्टीप्लाई करो तो किलोमीटर पर आवर में आ जाएगा. दैट विल बी नियरली 88 जो उन्होंने दिया है kilometer per hour. ठीक है, it will be 88, but we don't want it to do because as per Maharashtra State Board our final answer should be in SI unit compulsorily. So SI unit meter per second है, so let us keep it in meter per second only. So they are asking कि by how much can the upper speed limit exceed in this case. So upper speed limit will not exceed, students. The upper speed limit will not exceed in this case because the angle of banking मिला है ना हमें यहाँ पे, it is 78 degree 68 minutes. It is more than 45 degree. इट इज नॉट एक्सपेक्टेड कि 45 डिग्री से ज्यादा एंगल ऑफ बैंकिंग जाना चाहिए, इसके लिए यहाँ पे देर विल बी नो अपर स्पीड लिमिट इन दिस केस, ठीक है, यहाँ पे अपर स्पीड लिमिट नहीं होगा because angle of banking is greater than 45 degree. So the reason which you will write over here is, as the angle of banking is greater than 45 degree, there will be no upper speed limit. ठीक है, the angle of banking should be less than 45 upper speed होने की, ठीक है. Next, during a stunt, a cyclist considered to be a particle is undertaking a horizontal circles inside a cylindrical well of radius is given 6.05 meters. You have been given the radius of the cylindrical well. R is given to you. R is given to you as 6.05 meter, and if necessary the friction coefficient is 0.5. Mu value is given to you as 0.5. How much minimum speed should the stunt artist maintain? Minimum speed V पता करना है. V minimum speed for the stunt artist. The mass is given as 50 kg, and if he or she increases the speed by 20%, what will be the force of friction? You have studied well of death का formula. Well of death का formula का ये example यहाँ पे है. This is a numerical based on well of death. So we know that well of death में minimum velocity is equal to root rg upon mu. This is the formula. ठीक है, root rg upon mu. So r is given to 6.05. So v minimum will be equal to root of 6.05 into g value. They have not given, take 10, 0 divided by 0.5. Okay. So when you solve this, you get the value for this particular case. That will be nearly 11 meter per second. Nearly 11 meter per second will be the particular value. Nearly the minimum velocity which you will find over here is 11 meter per second. It is an approximate answer, nearly 10.88 something you will get. It's okay, you can write it as 11. 10.8 आएगा तो भी चलेगा. Second thing they have asked is force. So force formula, in that case we know that the formula for force F is equal to mg. So m कितना दिया है 50, g is 10, so that will be 500 newton. Force का formula होता है mg. In case of well of death, in the derivation itself we have drawn the diagram. तो डायग्राम में जो फोर्स ऑफ फ्रिक्शन था वो mg से बैलेंस हुआ था. इट इज फ्रॉम द डायग्राम. आई एम नॉट टेकिंग दिस फॉर्मूला एनी हाउ. द फॉर्मूला F इक्वल टू mg इज फ्रॉम द डायग्राम. इफ यू सी द डायग्राम ऑफ वेल ऑफ डेथ, उसमें हॉरिजॉन्टल, उसमें वर्टिकल फोर्स जो F है, फोर्स ऑफ फ्रिक्शन, दैट इज बैलेंस्ड बाय mg. सो दिस इज अ वेरी स्मॉल न्यूमेरिकल. It is a very important one. A pendulum consisting of a massless string, say of length is given to you 20 centimeter and a tiny bob of mass 100 gram. So length of the pendulum is given to you 20 centimeter. I can say it is 0.2 meter, or I can say 20 into 10 raised to minus 2, whatever. And a tiny bob of mass 100 gram. 100 gram means 0.1 kg is given to you, and set up into conical pendulum. It performs 75 rpm. The frequency is given as 75 rpm. Yeah, now this is rpm means revolution per minute. You need to convert revolution per minute to revolution per second, because rpm is a cgs unit. revolution per minute को revolution per second में करेंगे, divide by 60, rps हो जाएगा. revolution per minute को revolution per second में when you convert, it will be 60. Nearly I can say it is 1.25. इसको सॉल्व करो तो 1.25 rps मिलेगा. 75/60. Calculate the kinetic energy of the pendulum. Kinetic energy and increase in gravitational potential energy. So two things: potential energy, kinetic energy. Again, they have told use pi square equal to 10. So it is a benefit for us. Whenever we have pi square, we will use it as 10. Now, since n is given to you, since n is 1.25, I can find time period. Time period is 1 upon n. So that is 1 upon 1.25. So 1 upon 1.25, you can go through reciprocal table and find the value. Those who don't know how to find the reciprocal value, please go through in the logarithm playlist. There I have reciprocal के लिए भी एक video है, so you can refer that. So this is 0.8 second. Using reciprocal table in your logbook, you can find this value. It is 0.8 second. Now, why did I find this time period? Because I need to find kinetic energy and potential energy of this pendulum. Okay. Now, we don't have direct formula for conical pendulum ka kinetic and potential energy. We, in our derivation, in our textbook, we have conical pendulum's time period formula. We know that time period of conical pendulum is 2 pi रूट एल कॉस थीटा अपॉन जी, दिस इज द टाइम पीरियड ऑफ कोनिकल पेंडुलम, ठीक है। सो यहाँ से हमें टाइम पता है, टी इज नोन टू अस, एल भी पता है, जी भी पता है, कॉस थीटा नहीं पता। what do you do? Square this formula. When you square this formula, you will get t square equal to 4 pi square l cos theta by g. So therefore इससे cos theta का वैल्यू निकालो, cos theta हो जाएगा g t square upon 4 pi square l, right? When you just cross multiply or rearrange the term, you get cos theta equal to g t square upon 4 pi square l. When you substitute the value, t का value, g का value and 4 pi square का वैल्यू, ओके पाई स्क्वायर के जगह पे यू कैन टेक जी, पाई स्क्वायर के जगह पे यू कैन टेक 10, तो जी और पाई स्क्वायर कट हो जाएगा, ठीक है। सो दैट इज इजियर फॉर कैलकुलेशन। एल का वैल्यू व्हेन यू सब्स्टिट्यूट यू गेट cos थीटा इज 0.8, cos theta का वैल्यू you will get it as 0.8. I'm not substituting and showing you, it's just a small work that you can also do, okay? So cos theta will be 0.8. Now as I told you, we don't have kinetic and potential energy direct formulas given to us, so we will have to, I'll give you the formula. The potential energy formula is given by mgl 1 minus cos theta, इसलिए हमने पहले cos theta का वैल्यू निकाला बिकॉज उसमें cos theta का वैल्यू आता है, तो the potential energy is given by mgl 1 minus cos theta. Again when you substitute the value and solve, you will get it as 0.04 joule. The answer will be 0.04. Just a simple formula, you need to memorize this formula for conical pendulum. Anyhow in entrance you will have to do, if you are paying, if you are going for entrance you will have to do. So here also you can just solve this. So you have been given that potential energy का formula is 0.04. As far as kinetic energy is concerned, kinetic energy के लिए भी you have the similar type of formula. So kinetic energy, the formula is given by kinetic energy equal to half m into 2gl 1 minus cos theta. This is the formula. This is the formula for kinetic energy. Half m 2gl 1 minus cos theta in bracket. So when you solve this, you get 0.045 joule as your answer. I mean, both answers will be similar. There is no much difference between the two. Both answers will almost be similar. Okay. So this is nearly 0.04, 0.045. This is kinetic energy and potential energy formula. There is alternate method also to do, but if you just memorize the formula, it's also fine. A motorcyclist is undergoing a vertical circles inside the sphere of death. So again, one more question on sphere of death is given to you. Sphere of death means well of death itself, that is given to us. And the speed of the motorcycle varies between 6 and 10 meter per second. This is given to you. There are two velocities which are given to us, 6 and 10. Let us assume the first velocity is v1, that is 6 meter per second, and the second velocity is v2, that is 10 meter per second. Calculate the diameter of the sphere. You are supposed to find the diameter of the sphere. How much minimum velocities are possible for these two speeds? How much minimum velocity we will find out using vertical circular motion, because there it is told na vertical circles हो रहा है इसमें, तो vertical circular motion का use होगा. In case of vertical circular motion, we have done the derivation and we have seen, we have got one formula in that, v2 square minus v1 square equal to 4rg. Now this is actually derivation के बीच में एक step आता है, ये वहां से उठाया है formula. Derivation करेंगे तो उसमें एक ये term आता है वो derivation करते समय. So you get v2 square minus v1 square equal to 4rg. From here we will find the diameter. ठीक है. So for here I can say, I can write this as v2 square minus v1 square equal to 4 into radius can be written as diameter upon 2 into g, because I need to find diameter ना, तो मुझे diameter के terms में convert करना पड़ेगा. So this will be 2. So I can say v2 square minus v1 square equal to 2 dg, right? So therefore I can write diameter equal to v2 square minus v1 square upon 2g, and when you substitute the value, you get the diameter value as 3.2 meter. So substitute करो, you get the value 3.2. v2 is given to you, v1 is given to you. 10 square minus 6 square upon 2 into g, g का value 10 ले लो, चलेगा. So you will get this as 3.2. What is the minimum speed they are asking? How much minimum speed are possible? So from vertical circular motion, VCM, the minimum speeds in the derivation we have seen, the minimum speeds are v1 equal to root of rg and v2 equal to root of 5rg. ठीक है. So पहले v1 निकालेंगे. So let us first find the v1. So to find the v1, you will have to find radius, because r चाहिए ना. So again r, so it is simple, since you know the diameter you can find. So यहाँ से I can say r will be equal to 1.6. Diameter 3.2, r 1.6. So v1 will be equal to root 1.6 into 10. Root 1.6 into 10 will be root 16 is 4 meter per second. So the minimum speed possible is 4. सी ये मिनिमम स्पीड क्या है, मोटरसाइकिलिस्ट का जो वेलोसिटी दिया है ना v1 v2, ये इतने वेलोसिटी पे जा रहा है, इतने वेलोसिटी पे इट इज मेकिंग वर्टिकल सर्कल। इससे कम का भी कोई वेलोसिटी पॉसिबल है क्या, दैट इज व्हाट यू आर सपोज टू फाइंड। कितना कम वेलोसिटीज पे वो सर्कुलर मोशन कर सकता है, दैट इज व्हाट यू आर सपोज टू फाइंड। दिस v1 v2 विच इज गिवन टू यू, ये मोटरसाइकिलिस्ट का वेलोसिटी है, he is already making a motion with this velocity, but the question is asking, is there any other minimum velocity apart from this which is given to you? So it is there which we have found out, मतलब minimum उसको 4 maintain करना पड़ेगा, ठीक है। और उसका velocity if you see 4 से ज्यादा ही है ना 6, means it will not fall, the motorcyclist will not fall in the circle because it is more than the 4 velocity, that is 6 given to you। v2 का वैल्यू होता है √5 r, so √5 into 1.6 into 10, so that will be 4 √5, right? 4 √5 meter per second. Again, that will be greater than, sorry, it will be less than 10 only, it will be less than 10, 4 √5 nearly around 8 something आएगा, कुछ तो 8 point something आएगा, 10 से कम ही आएगा, ठीक है। मतलब the 6 and 10 values are almost perfect values for the motorcyclist to take circular motion, ठीक है। A metallic ring is given to you of mass 1 kg and moment of inertia I is given to you 1 kg meter square is given to you when rotating about one of its diameters. Okay, when rotating about one of its diameters, please refer to page yellow table, please refer to the yellow table which is mentioned in your textbook before the exercise। वहां पे से तुम्हें moment of inertia के बहुत सारे values मिलेंगे and you will have to memorize that table for different moment of inertia in the textbook, ठीक है। I guess it is on page number 22 of your textbook if I'm not wrong, it is on page nearly around 21 22 पे मिल जाएगा। Just check, there is one yellow table, you have to memorize the moment of inertia values। It is molded and remolded into a thin uniform disc, ठीक है। तो पहले तो क्या था, रिंग था, the initial shape which was given to you was ring, एक रिंग था जिसका moment of inertia is given to you and जिसका mass is given to you 1 kg, moment of inertia and mass is given to you। So ring के लिए about the diameter, about one of the diameter, so moment of inertia of ring about the diameter, about the diameter, if you refer the yellow table, I am directly writing here the formula, that formula is mr square upon 2, half mr square, that is mr square upon 2, that is the given formula from the table। So इससे radius निकाल लो, तो radius कितना हो जाएगा, okay, I is given to you ना, so just find the value of radius from here। So if you see here, so this is 1 will be equal to 1 into r square upon 2, so r square will be equal to 2, or I can say r will be equal to √2 meter, right? R will be equal to √2 meter, right? वन मोमेंट ऑफ इनर्शिया भी 1 है, मास भी 1 है, तो एवरीथिंग इज 1, खाली 2 बचेगा ना, तो r स्क्वायर विल बी 2, तो रेडियस ऑफ द रिंग इज √2। क्वेश्चन क्या बोल रहा है, इफ इट इज मोल्टन एंड रीमोल्डेड इनटू अ थिन यूनिफॉर्म डिस्क ऑफ द सेम रेडियस, मतलब ये रिंग का डिस्क बनाया गया जिसका रेडियस सेम है, सो इट इज गिवन दैट रेडियस ऑफ रिंग and disk are same, so radius of disk will also be equal to √2 only, therefore I can write radius of disk is also, this is radius of ring, ठीक है। रेडियस ऑफ रिंग इज √2, तो रेडियस ऑफ डिस्क भी √2 ही होगा, दोनों सेम ही दिया है। हाउ मच विल बी इट्स मोमेंट ऑफ इनर्शिया व्हेन रोटेट अबाउट ओन एक्सिस, ओन एक्सिस मतलब सेंट्रल एक्सिस, टेक्स्ट बुक में वर्ड सेंट्रल वर्ड यूज किया गया होगा, सेंट्रल एक्सिस मतलब ओन एक्सिस होता है। तो कितना मोमेंट ऑफ इनर्शिया होगा, अभी शेप चेंज हो गया, अभी रिंग नहीं है, अभी डिस्क का फॉर्मूला, यू विल हैव टू सी द फॉर्मूला फॉर द डिस्क। क्वेश्चन में इनिशियली द डेटा वाज गिवन फॉर रिंग, रिंग का मोमेंट ऑफ इनर्शिया से हमने उसका रेडियस निकाला, एंड देन नाउ द क्वेश्चन इज आस्किंग कि सेम रेडियस का अगर डिस्क लिया गया तो उसका मोमेंट ऑफ इनर्शिया क्या होगा अबाउट द सेंट्रल एक्सिस। सो मोमेंट ऑफ इनर्शिया ऑफ द डिस्क का फॉर्मूला भी वही है, सेंट्रल एक्सिस के लिए सेम फॉर्मूला है mr²/2। तो कितना मोमेंट ऑफ इनर्शिया होगा, तो मास भी सेम है बिकॉज इट इज वही चीज को रिमोल्ड किया गया है ना, तो मास भी सेम होगा 1, 1 into √2² 2, दैट विल बी अगेन इक्वल टू 1 ओनली, आंसर 1 ही आएगा, सॉल्व करेंगे तो यू गेट 1, ठीक है। सो द मोमेंट ऑफ इनर्शिया ऑफ द डिस्क इज आल्सो 1। A big dumbbell is prepared by using a uniform rod of mass 60 grams, rod mass का दिया हुआ है rod के लिए 60 grams, length of the rod is given to you 20 centimeter, two identical solid sphere जिसका mass of sphere is given to as 25 grams। Now here there is a confusion in the textbook, कुछ टेक्स्ट बुक्स में 25 ग्राम वैल्यू दिया है. इवन द डेटा विच आई हैव टेकन इज विद रिस्पेक्ट टू द न्यू सिलेबस इन द सेंस जो न्यू एडिशन 2023 2024 में जिन्होंने नया टेक्स्ट बुक लिया है ना, उनके बुक्स में 25 ग्राम लिखा होगा. जिन्होंने पुराना टेक्स्ट बुक लिया है उनके बुक में 50 ग्राम लिखा होगा. सो देयर इज अ चेंज इन द क्वेश्चन. सो यू कैन सॉल्व. I will prefer you to solve it using new textbook because new value में डेटा वैसा दिया है 25 ग्राम. ठीक है, बट इट विल नॉट बी रॉन्ग इफ यू सॉल्व बाय 50 ग्राम. एनी कुछ फर्क नहीं पड़ेगा, आंसर अलग अलग आएगा. बस डेटा अलग लेंगे तो आंसर अलग ही आएगा ना. फॉर्मूला तो सेम ही यूज करना है, मेथड भी सेम यूज करना है. तो इवन इफ यू सॉल्व बाय 50 ग्राम कुछ गलत नहीं है. सॉल्व तो कोई भी वैल्यू करके करो. बोर्ड एग्जाम में नेसेसरी नहीं है सेम वैल्यूज ही आएगा, वहां पे भी अलग वैल्यूज आ सकता है. So whether you take 25, whether you take 50, whatever value is given, you take whatever is given in your textbook. I am preferring over here new textbook. जिसके पास न्यू नया 2023 2022 का टेक्स्ट बुक होगा, नया वाला न्यू एडिशन का, वो है. जो जो जब भी फर्स्ट टाइम टेक्स्ट बुक बना था वो बुक में 50 ग्राम दिया है. सो दैट इज अ मिस्टेक इन दैट बुक वी कैन से. एनी हाउ वी कैन टेक 50 ऑल्सो, नो नीड टू वरी. द आंसर चेंज हो जाएगा. मैं बता दूंगा अगर 50 लिया तो आंसर क्या आएगा. इवन दैट आई विल लेट यू नो. So mass of the sphere is given, radius of the sphere is given to you as a 10 centimeter. If you see everything is in CGS ना, तो सब CGS में रखो. हम लास्ट में फाइनल आंसर को SI में कन्वर्ट कर देंगे. प्लीज रिमेंबर स्टूडेंट्स, बोर्ड का रूल है यू विल हैव टू राइट योर फाइनल आंसर इन SI यूनिट्स ओनली. सो इट इज कंपल्सरी फॉर यू टू राइट इन SI यूनिट. बट यहाँ पे सब CGS में दिया हुआ है तो अभी सब CGS में रहने दो. एट द एंड फाइनल आंसर में हम डायरेक्ट SI में कर देंगे. ठीक है. So calculate the moment of inertia of the dumbbell. Please remember the moment of inertia of dumbbell का formula is given by 1/12 mass of rod, length of rod का square plus 2 mass of sphere 2/5 r square plus l square. ये रेडियस ऑफ स्फीयर है, ये लेंथ ऑफ रॉड है. ठीक है, ये 2 है. इधर सिर्फ 2 होगा. 2 टाइम्स मास ऑफ. ये फॉर्मूला याद रखना है, ये हमारे बुक में दिया नहीं है फॉर्मूला. ये डायरेक्ट फॉर्मूला मैंने आपको दे रहा हूँ. दिस इज डायरेक्ट फॉर्मूला टू रिमेंबर द मोमेंट ऑफ इनर्शिया ऑफ अ डंबल. डंबल का मोमेंट ऑफ इनर्शिया का फॉर्मूला होता है 1/12 मास ऑफ रॉड इनटू लेंथ ऑफ रॉड का स्क्वायर प्लस 2 टाइम्स मास ऑफ स्फीयर ब्रैकेट 2/5 रेडियस ऑफ स्फीयर स्क्वायर प्लस लेंथ ऑफ रॉड स्क्वायर. नाउ जस्ट सब्स्टिट्यूट द वैल्यू. 1/12 into mass of rod का वैल्यू 60 into 20 square plus 2 into mass of sphere 25 gram into 2/5 radius of sphere is 10 का square plus length of rod is 20 का square. When you solve this you get this as 2000 and this as 22,000. ये प्लस के पहले वाला टर्म 2000 मिलेगा, प्लस के बाद वाला टर्म 22,000 मिलेगा. आंसर आएगा 24,000 ग्राम सेंटीमीटर स्क्वायर. ठीक है, वी कैन कन्वर्ट ग्राम सेंटीमीटर स्क्वायर टू केजी मीटर स्क्वायर. इवन दैट इज फाइन, वी कैन कन्वर्ट दैट. एनीहाउ ये एक आंसर है. मैंने बोला कि कुछ बुक्स में 50 ग्राम भी दिया है. सो व्हाट विल हैपन इफ यू टेक 50 ग्राम, उसका भी आंसर आई विल लेट यू नो. सपोज इंस्टेड ऑफ दिस 25 आई एम टेकिंग मास ऑफ दिस स्फीयर एज 50 ग्राम्स. ठीक है, नो नीड टू वरी, यू कैन टेक 25, यू कैन टेक 50. बोर्ड एग्जाम में वैल्यू चेंज होके भी आता है, तो इट इज नॉट नेसेसरी दैट यू नीड टू यूज दैट ओनली. जो भी बुक में दिया यूज करो, सेम फॉर्मूला यूज करो. व्हेन यू सब्स्टिट्यूट ओवर हियर ना, यू गेट I इक्वल टू दिस वैल्यूज. व्हेन यू सॉल्व ओवर हियर दिस 1 विल बी इक्वल टू, ये तो 2000 रहेगा. फर्स्ट टर्म जो है इसमें तो कोई चेंजेस नहीं आएगा, ये सेम रहेगा 2000. सेकंड टर्म में इधर 50 हो गया ना, इधर 50 आ जाएगा. इधर 50 होने की वजह से ये वैल्यू 22,000 नहीं आएगा, इसके जगह पे आएगा 44,000 वैल्यू हो जाएगा, डबल हो जाएगा उसका. दिस विल बी 46,000 ग्राम सेंटीमीटर स्क्वायर. बट अगेन देयर इज अ टेक्स्ट बुक में देयर इज अ मिस्टेक. जिसके बुक में 50 ग्राम दिया हुआ है ना, उसके बुक में भी आंसर 24,000 ही दिया हुआ है. ठीक है, सो वी कैन से दैट देयर इज अ मिस्टेक इन द क्वेश्चन इटसेल्फ. इफ द आंसर इज 24,000 देयर इज अ मिस्टेक इन द क्वेश्चन. मास शुड बी 25 ग्राम ओनली. ठीक है, मास 25 ग्राम ही होना चाहिए, क्योंकि जिसके बुक में 50 ग्राम भी दिया है मास, उसके बुक में भी 24,000 ही आंसर दिया है, विच इज रॉन्ग. देन विच इज रॉन्ग. तो आंसर अगर 50 ग्राम लेके चलेंगे तो आंसर रॉन्ग है. अगर आंसर राइट लेके चलना है तो क्वेश्चन में चेंज करना पड़ेगा. ठीक है, सो प्लीज रिमेंबर इट इज बेटर दैट यू टेक रेफर द न्यू टेक्स्ट बुक. न्यू टेक्स्ट बुक में मास ऑफ स्फीयर इज 25 ग्राम, वो लेके चलो, आंसर भी राइट आएगा, क्वेश्चन में भी मिस्टेक नहीं रहेगा. ठीक है, बट इफ इन योर बुक दे हैव गिवन 50 ग्राम, तो उन्होंने आंसर में मिस्टेक किया है, वहां पे भी 24,000 ही दिया है, विच इज रॉन्ग. आंसर शुड बी, सॉरी आंसर उन्होंने हाँ 24,000 दिया है, बट अगर 50 ग्राम लेंगे तो 46 आंसर आएगा. Anyhow, you can refer to 25 gram only. That is better. Next, a flywheel used to prepare earthenware pots is set into set into rotation at 100 rpm. Okay, so next they have been given the frequency again 100 rpm दिया हुआ है. What will you do? You will convert rpm to rps. ठीक है, तो क्या करेंगे? As I told you, so frequency is given to you 100 rpm converted to rps, तो 100 upon 60 rps हो जाएगा. So this will be how much? This will be 5 by 3 rps. 5 by 3 लिखा तो भी चलेगा, इसको पॉइंट में किया तो भी चलेगा. देखते हैं कैसा काम आता है. लेटेस्ट इसको मैं फर्स्ट फ्रीक्वेंसी दे देता हूँ, से n1, बिकॉज क्वेश्चन में और एक फ्रीक्वेंसी दिया है लास्ट में. तो फर्स्ट फ्रीक्वेंसी इज 100 आरपीएम इज गिवन टू यू. इट इज इन द फॉर्म ऑफ डिस्क. डिस्क इज गिवन. डिस्क का मास दिया. ओके, मास दिया हुआ है 10 kg and radius is given to you 0.4 meter. A lump of clay is to be taken equivalent to a particle of mass 1.6 kg. Mass of clay is given to you 1.6 kg. Falls on it and adheres to it at a distance x from the center. सपोज अगर ये एक फ्लाईव्हील है, ये इसका एक्सिस है, ठीक है. यहाँ पे कहीं पे तो सपोज क्ले गिरता है. सपोज यहाँ पे कहीं पे तो क्ले गिरता है जिसका मास वगैरह सब दिया हुआ है. इसका डिस्टेंस सेंटर से एक्स है. इसका डिस्टेंस सेंटर से एक्स है. ये एक्स का वैल्यू ही हमें पता करना है. ये एक्स का वैल्यू पता करना है. सपोज अगर ये क्ले है तो मैं क्ले के अराउंड भी एक एक्सिस ले लेता हूँ. सो दिस इज ऑफ द पैरेलल थ्योरम ऑफ पैरेलल एक्सिस जैसा हो गया ना ये क्वेश्चन. दो एक्सिस हो गया ना. थ्योरम ऑफ पैरेलल एक्सिस में दो एक्सिस होता है. ठीक है, एक तो सेंट्रल एक्सिस होता है और एक तो दूसरा एक एक्सिस हम कंसिडर करते हैं पैरेलल एक्सिस. तो यहाँ पे सपोज अगर मैंने क्ले का भी एक्सिस कंसिडर किया तो क्ले का एक्सिस दो एक्सिस हो जाएंगे. एक तो सेंट्रल एक्सिस, एक क्ले का एक्सिस. एंड दोनों के बीच में एक्स डिस्टेंस जो है वो हमें पता करना है. सो यूजिंग थ्योरम ऑफ पैरेलल एक्सिस वी कैन सॉल्व दिस क्वेश्चन. मैं सेकंड फ्रीक्वेंसी 80 आरपीएम दिया है, इसको भी 80 by 60 कर दो. दैट विल बी 4 by 3, दैट इज 1.33 rps. Anyhow, so now let us solve it using theorem of parallel axis. And you will have to use two things. एक तो theorem of parallel axis यूज करना पड़ेगा, एक दूसरा यूज करना पड़ेगा conservation of angular momentum. ठीक है, two things we will have to use. So from theorem of parallel axis you will have to find the second moment of inertia, and you will have to find the distance x, and second moment of inertia हम पता करेंगे इससे angular momentum, conservation of angular momentum. So let us use conservation of angular momentum first. Conservation of angular momentum, दोनों L सेम होगा. L1 इक्वल टू L2. सो L का फॉर्मूला I ओमेगा. सो I1 ओमेगा 1 इक्वल टू I2 ओमेगा 2. नाउ अगेन इफ यू सी, ओमेगा नहीं दिया है ना, R N दिया है. सो I1 इंटू ओमेगा के जगह पे 2 पाई N1 इक्वल टू I2 इंटू ओमेगा के जगह पे 2 पाई N2. You see 2 pi cancel, so you are left out with I1 into N1 equal to I2 into N2. So from here I can find, ओके, I1 का वैल्यू हम यहाँ से निकाल सकते हैं. I1 फर्स्ट वाले का डेटा दिया है ना, फर्स्ट वाले का मास दिया हुआ है, उसका रेडियस दिया हुआ है. जो फ्लाईव्हील है, फ्लाईव्हील का मास एंड ये दिया है ना यहाँ पे. फ्लाईव्हील के लिए यू हैव बीन गिवन द मास एंड रेडियस. सो फ्लाईव्हील का मोमेंट ऑफ इनर्शिया हम ना I1 का वैल्यू वी कैन फाइंड आउट. एंड व्हेन यू फाइंड आउट द I1 वैल्यू, I1 भी mr² by 2. mr² by 2. फ्लाईव्हील मतलब डिस्क. फ्लाईव्हील इज अ डिस्क. ठीक है, सो डिस्क का ही मोमेंट ऑफ इनर्शिया mr² by 2 into n1 equal to I2 into n2. So when you solve this, on solving this you will get the value of I2. यहाँ से I2 का वैल्यू मिल जाएगा. ठीक है, so I2 will be equal to mr² by 2 into n1 upon n2. So when you solve this you get the value of I2 from here. So the value of n2, when you substitute the value, I'm not substituting the value and showing, you can just substitute and check. The value of n2 will be 1.004. 1.004 will be the value for I2. I2, not n2. I2 का वैल्यू. I2 का वैल्यू, when you put the value, you will mr². M का वैल्यू ये लेना है 10 kg. M value will be 10 kg. R value will be this. And mr²by 2 n1 upon n2, ये जब मल्टीप्लाई करेंगे you get 1.004 kg meter square for I2 value. Now I2 मिल गया. As I told you, there are two axes ना, ये एक्सिस है और ये एक्सिस है. तो इसमें थ्योरम ऑफ पैरेलल एक्सिस यूज करना पड़ेगा. ठीक है, सो व्हेन यू यूज थ्योरम ऑफ पैरेलल एक्सिस, okay, I'll just erase this slide. So using theorem of parallel axis, I can write I2 equal to I1 plus m into x square. X is the distance that I need to find. Actually, the formula is I2 equal to I1 plus mh square in the derivation. H is the distance between the two axes. But यहाँ पे x बोला है ना, तो x ले लेंगे. I2 equal to I1 plus mh square. So I2 we know I1 का वैल्यू mr स्क्वायर है, ये भी mr स्क्वायर बाई 2, ये भी हमें पता है, प्लस m into x स्क्वायर. आई एम सपोज टू फाइंड x स्क्वायर. So I2 value 1.004 equal to mr square by 2. When you solve mr square by 2, 0.8 मिलेगा. प्लस मास ऑफ द क्ले इज गिवन टू, ये मास ऑफ क्ले आएगा यहाँ पे क्योंकि क्ले के बारे में ना, तो मास ऑफ द क्ले 1.6 into x square. So therefore 1.004 minus 0.8 upon 1.6 equal to x square. So therefore when you solve this, you get x square equal to 0.127 something. So therefore x will be equal to root of 0.1275 and therefore x will be equal to 0.356 meters, nearly 0.356 meters. That is the value for x. So using theorem of parallel axis, you will find the x, that is the distance, that is ours. Last question from the chapter. Starting from the rest, they have been told starting from the rest. Starting from rest means initial velocity will be assumed as 0, u is 0. Since u is 0, the question is telling an object rolls down an inclined plane. So u is 0. That rises by 3 in every 5. Please remember, the rises by 3 in every 5 का मतलब है sin theta का वैल्यू दिया है 3/5. Rises by 3 in every 5 is given as sin theta का वैल्यू, that is 3/5. This is a way of writing sin theta. ठीक है, sin theta को हम ऐसे लिखते हैं, जब इंग्लिश में लिखना हो तो we write it rises by n number in every n number, ऐसा होगा. So अगर सपोज क्वेश्चन में आता है it rises by 4 in every 6, तो साइन थीटा कितना होगा 4/6. पहला वैल्यू डिवाइड बाय सेकंड वैल्यू, जो पहला वैल्यू दिया है, तो पहला वैल्यू यहाँ पे 3 दिया है, बाद में जो वैल्यू दिया है 5, तो 3 डिवाइड बाय 5 करो, दैट इज अ साइन थीटा. साइन थीटा वैल्यू इज गिवन. The object gains a speed is given to you root 10 meter per second as it travels a distance 5/3. S is the distance 5/3 meter along the incline. Let us assume there is an incline over here. ठीक है, ये थीटा है, ये डिस्टेंस s है, ये इसका हाइट है, so ये थीटा है. तो फ्रॉम डायग्राम यू कैन से साइन थीटा इक्वल टू h अपॉन s. आई कैन फ्रॉम डायग्राम आई कैन से साइन थीटा इक्वल टू h अपॉन s. बराबर है ना, s दिया हुआ है, साइन थीटा भी दिया हुआ है, तो इससे आई कैन से h विल बी इक्वल टू s इनटू साइन थीटा. बराबर है, व्हेन यू क्रॉस मल्टीप्लाई आई कैन से साइन थीटा इज h अपॉन s, सो h विल बी इक्वल टू s इनटू साइन थीटा. s 5/3 और साइन थीटा दिया है 3/5, सो दैट विल बी 1. तो हाइट कितना दिया है 1 मीटर. हाइट हमने ऐसे निकाला है. ये कहां से आया, अगेन डेरिवेशन, रोलिंग मोशन का डेरिवेशन है. डेरिवेशन ऑफ रोलिंग मोशन इज गिवन टू यू इन योर टेक्स्ट बुक. ये डेरिवेशन का डायग्राम है, वहां से फॉर्मूला लिया है. ठीक है, एंड इन दैट केस द क्वेश्चन इज आस्किंग व्हाट आर द पॉसिबल शेप्स ऑफ एन ऑब्जेक्ट. स्टूडेंट्स प्लीज रिमेंबर द पॉसिबल शेप्स ऑफ एन ऑब्जेक्ट आर गिवन बाय फाइंडिंग द k स्क्वायर बाय r स्क्वायर वैल्यूज. किसी भी ऑब्जेक्ट का शेप पता करना है तो उसका k स्क्वायर बाय r स्क्वायर का वैल्यू पता करो, उससे तुम्हें उसका शेप मिल जाएगा. ठीक है, ऑलवेज रिमेंबर k स्क्वायर बाय r स्क्वायर. तो k स्क्वायर बाय r स्क्वायर कहां से आएगा, वेलोसिटी दिया है ना क्वेश्चन में, वेलोसिटी का फॉर्मूला v इक्वल टू रूट 2gh अपॉन 1 प्लस k स्क्वायर बाय r स्क्वायर. तो देखो यहाँ पे h भी है ना, तो इसलिए मैंने पहले h निकाला, h है यहाँ पे, एंड यहाँ से 1 प्लस k स्क्वायर बाय r स्क्वायर से k स्क्वायर बाय r स्क्वायर निकालना है. सो यहाँ से क्या मिल जाएगा, इसका स्क्वायरिंग कर दो पहले तो, या तो यू कैन सब्स्टिट्यूट द वैल्यू, दैट विल बी बेटर. v का वैल्यू है रूट 10 इक्वल टू रूट 2 इंटू 10 इंटू h का वैल्यू 1 अपॉन 1 प्लस k स्क्वायर बाय r स्क्वायर. रूट कैंसिल हो जाएगा दोनों तरफ से. 10 विल बी इक्वल टू 2 इंटू 10 अपॉन 1 प्लस k स्क्वायर बाय r स्क्वायर. अगेन 10 भी कैंसिल, तो 1 प्लस k स्क्वायर बाय r स्क्वायर विल बी इक्वल टू 2. तो k स्क्वायर बाय r स्क्वायर का वैल्यू कितना होगा, 2 माइनस 1 दैट इज 1. k स्क्वायर बाय r स्क्वायर का वैल्यू 1. स्टूडेंट्स के स्क्वायर बाय आर स्क्वायर का वैल्यू 1 जो है रिंग या सिलेंडर के लिए होता है. के स्क्वायर बाय आर स्क्वायर का वैल्यू जो 1 वैल्यू है ना, दिस इज फॉर अ रिंग और अ सिलेंडर. दिस इज गिवन इन योर टेक्स्ट बुक. रोलिंग मोशन के डेरिवेशन के बाद नोट में दिया हुआ है रिंग और अ सिलेंडर. सो व्हेनेवर देयर इज इन द क्वेश्चन इज बीन आस्क्ड कि फाइंड द पॉसिबल शेप ऑफ एन ऑब्जेक्ट, तो पॉसिबल शेप ऑफ द ऑब्जेक्ट विल बी रिंग और अ सिलेंडर. ये कैसे पता चलेगा, के स्क्वायर बाय आर स्क्वायर. इफ यू फाइंड द वैल्यू ऑफ के स्क्वायर बाय आर स्क्वायर, यू विल गेट द पॉसिबल वैल्यू ऑफ द shape which is given to you. Okay, so this was the last question for our rotational dynamics chapter.